Okay, next topic to discuss is Internet Key Exchange, either IKE. Basically, Internet Key Exchange provide framework to exchange security parameter between two IPsec pair. So suppose you have a side-to-side VPN, either remote access VPN, which is through IPsec. So these two are your IPsec pairs. Okay, this side it can be a router or any vendor firewall, and this side can also be any vendor firewall or it can be a router. So they can make a site to site VPN. Now we need such a solution, okay, so they can exchange the security parameter. So these are the security parameter, which is also called Hagels, H-A-G-L-E. Hagels means H means hash, and then authentication, then group, then lifetime, and then encryption. Because when you are trying to configure IPsec, you need to define these things. So if I go to the router configuration, so here I say crypto ISA-KMP policy. So there is authentication, there is encryption, there is group, there is hash, there is a lifetime. And similarly, you need to configure similar thing on the other side of the IPsec pair. It can be a router or firewall. So who is doing this set to exchange with each other? These peer negotiation. So this is through Ike. We call them Internet Key Exchange. So Ike is a protocol used to set up IPsec security association security attributes. So they will exchange between two IPsec pairs these security association and these security parameter with each other. So suppose I have R1 which has a tunnel with R2, and also R1 has a tunnel with R3, side to side VPN and side to side VPN. So if I go to R1 and if I check show running section, okay, sorry. So if I check, so these are the parameter which is configured on this side, like ISA-KMP policy 5. So encryption is 3DS, authentication is pre-share key, DP-Hellman group is 2, and there is another policy which is between R1 to R3. So that one is also mentioned here similarly. So this is called, you need to mention the lifetime, which is the default one, is that's why it's not showing here. So it's not here. So show crypto ISA-KMP, and there is, I think so, one another command to see security association. Sorry, there is a policy. It's better to see policy and enter. So these are the parameter. Encryption algorithm is 3 key triple DS. So if I go up, so it means I use 3DS encryption. And hashing is secure hash standard. So hashing is, I choose hashing. Okay, so because that when we are using the default one, so that's why it's not mentioned here, but it's here. And authentication is pre-share key, and DP-Hellman group is this one, and lifetime is this one, 86400 second. So these are the parameter to exchange. That's why I mentioned here 5 security association to configure. We call them security association as well. So who is doing this for us is IKE in the first phase. So Internet Key Exchange used to set up IPsec security association security attributes, which I show you those security attributes. And similar things are configured on the other side of the router as well. So if I go to R2, it can be a router and it can be a firewall, it can be any device which support IPsec. So here is also 3DS, hash, pre-share key, and lifetime. So these are called Hagels as well. So who is doing this? IKE. This IKE, Internet Key Exchange, is responsible to exchange these information between two IPsec peers, either you can say the VPN peers. Then collection of parameter, if you are asking about security associations, so it is collection of parameter that two devices will use is called security association. So these are the parameter when the two devices exchange with each other, that which hash algorithm we gonna use, which authentication method we gonna use, which DP-Hellman group will use, what will be the lifetime of the VPN, the first phase, and what will be the encryption method. So these are called security association. So at least up to now it's clear to you. Now coming to IKE provide encryption key, encryption algorithm, mode between IPsec peer as well. What will be the encryption key? So in this case we are using 3DS encryption. What will be the hashing algorithm? We are using SHA. What will be the authentication method? We are using pre-share key. It can be a certificate base as well. And what will be the DP-Hellman group? We are using 2. And what is the lifetime? So it's 86400 second. I think so it's become 1 hour or something. Sorry, 1 day. So who is doing this for us? Is IKE. Is the responsible protocol. So IKE allow IPsec peer to dynamically exchange the key and negotiate IPsec SA. I just told you what is SA. So they can negotiate with each other and site-to-site VPN. And who gonna do this for us? Is IKE. So it means IKE is working under IPsec. And then IKE work with another 2-3 hybrid protocol. I think so I mentioned is here. So it's working with these protocol. So it means IKE is like a subcontractor under IPsec, and these 3 protocols are working under IKE. So IKE is the responsible, but IKE cannot do all these things. So it getting help from this one OKLEY, Oakley, and Scheme and ISAKMP, either ISAKMP, whatever you call them. So these 3 protocol, which is a hybrid protocol, and they helping IKE, and IKE helping IPsec to establish site-to-site either remote access VPN. So now it's clear. Now IKE has 2 versions, IKE version 1 and they have a new version, IKE version 2, which we will discuss a bit later. IKE version 1 was introduced in the year 1998 and it has been suppressed, and IKE 2 was introduced in the year 2005. So these are 2 versions which you can use for negotiation. ISAKMP, either ISAKMP protocol is a framework for exchange encryption key and security payload. Now this IKE getting help from this ISAKMP. That's why in the first one, when we are trying to configure VPN, if I go to configure and crypto policy, crypto ISAKMP, ISAKMP, and then here I type a policy, suppose 11, and enter question mark. So the first thing which we are creating, the first tunnel, so we are using ISAKMP, and then under the ISAKMP we are using authentication, encryption, DP-Hellman group, hash, lifetime. But before I say that IKE is doing this, yes, IKE is doing, but it getting help of ISAKMP, which is a hybrid protocol which helping IKE. And I believe I mentioned somewhere, which is this one. So IKE protocol is a hybrid protocol made from Oakley, Scheme and ISAKMP. So now for the first tunnel to create, IKE getting help of Isaac MP. That's why in the first tunnel when we are configuring, we are mention Isaac MP. Okay, now Internet Key Exchange use UDP port number 500. I will show you in Wireshark to send and receive the information. IKE protocol is a management protocol. Actually is use Isaac MP for key exchange. Yes, that's what I say, that Isaac MP, they are using this one for key management and for information sharing, for security association sharing in the first phase. That's why I mentioned here that peer negotiations are using IKE. I believe I mentioned somewhere, no, okay, but anyway in the first phase they are getting help of Isaac MP. Now IKE Internet Key Exchange protocol used to establish IPsec tunnel. Yes, this is what we are using, this IKE. IKE is the same with Internet Association Key Management Protocol. IKE built the tunnel for us, but it does not authenticate or encrypt the user data. Okay, we know this one. So this is the first phase. IKE will get help from Isaac MP to exchange these 5 security association, which we call them haggles, between 2 IPsec peers. Now in the second tunnel, what they will do, they will exchange the transform set IPsec policy detail, such as encapsulation. We will use authentication header or ESP, what will be the encryption method, hashing and tunnel mode, even though there is also lifetime for the second tunnel as well. So who is doing this for us? IKE with the help of some other protocol. Now coming to IKE versions. So IKE version, there is 2 version of IKE, IKE version 1 and IKE version 2. IKE version 1 was introduced around 1998 and was suppressed, and there is a IKE version 2 which was introduced in the year 2005. IKE version 2 does not consume as much bandwidth like a IKE. Also, it's required less configuration. IKE version 2 is faster. Also, there is a less what is called packet to exchange, and it's faster and it consume less bandwidth as compared to IKE version 1. So these are the main difference between IKE version 1 and IKE version 2. Now coming to Internet Key Exchange phases. Basically there are 2 phases to build IPsec tunnel, IKE phase 1 and IKE phase 2. I am talking about IKE version 1. In IKE version 1, there are 2 phases to establish the IPsec tunnel between 2 peers. The first phase is to exchange the security association between 2 devices, 2 IPsec devices. And the second one, and these are the 2 which I mentioned you, and the second one to exchange IPsec policies. So it means there are 2 phases to build the tunnel. So there is a phase 1 and there is a phase 2. There is Isaac MP tunnel and IPsec tunnel, and these are the port number. So phase 1 and phase 2, we call them different name as well, we will discuss a bit later. Now coming to the phase 1, IKE version 1, because there are 2 version of IKE, so don't confuse, there are 2 version, IKE version 1, phase 1. So in phase 1, 2 peer negotiate about the encryption, authentication and hashing. Yes, this is what we are doing. This is the first phase when we configure them and type crypto Isaac MP policy, and then we type the authentication and then the encryption and group hash and lifetime. So this is for the IKE phase 1. And about other protocol that may want to use in the phase 1. And when the main purpose of phase 1 is to establish secure tunnel which is to be used in phase 2. So it means first we create phase 1 tunnel, and this tunnel can be used by phase 2. Now this phase 1 tunnel is also called management traffic as well, management tunnel as well, which will be used by phase 2. So it clears the path and it makes secure channel for phase 2. So this is just a management traffic. The actual data will not be transferred in phase 1. So you get the idea. It will create a tunnel, and then phase 2 there will be another tunnel which will transfer the actual data. So phase 1 tunnel is a secure method to establish second tunnel, for second tunnel. Now in phase 1 there are two modes, main mode and aggressive mode. So it means in IKE version 1 there are two phases. In phase 1 there are two modes, main mode and aggressive mode. So this is IKE phase 1 where they exchange the haggles, where they exchange the 5 security association, hash authentication, group lifetime and encryption, two devices, and then they make a tunnel for data 1. This is called management tunnel as well. Now coming to which I was talking about, IKE phase 1 is two mode, main mode and aggressive mode. Main mode use 6 messages to exchange the information. So it is a long process. Three message will be sent by one IPsec pair, and 3 messages will be sent by the other one to exchange the information. Which information? Like a security association, authentication, hashing, DP element, then key exchange, and then they will decide the dynamic share secret key, and then they will start a tunnel which is called management tunnel. So these in main mode there are 6 messages exchanged between IPsec pairs. 3 messages by one pair and 3 messages by another IPsec pairs. So suppose if I have 2 devices here, if I have, so 3 messages will be exchanged by this side and 3 messages will be exchanged by this side to exchange all these information and to start the tunnel. This is main mode. I'm talking about main mode in the first phase 1. So the main purpose of IKE version 1 phase 1 to establish security association, which I told you. An internet key exchange main mode is considered more secure than aggressive mode. So main mode is more secure rather than aggressive mode. So in main mode, initiator pair that want to build the tunnel will send the first message. The one either devices which start the first message is called initiator. In the main mode, initiator send own proposal to responder and the other devices become a responder. So suppose if I have R1 and R2, so if this device start the communication first, so it's initiator and this R2 will be responder. But if this device start, then this become the initiator and this one will become the responder. So in the main mode, initiator send own proposal. Proposal means they will send their authentication, their every detail that I have these things, what you have. If it is matching, then they will start. So when the responder receive the first message from the initiator, it will reply back. So when one device receive the message, they will respond with that and they will reply back. The messages are used to inform initiator that we are agree upon the attributes. So if these two devices are using same everything, they will become agree. So let me send the packet to show you. So if I go to R1, I already start a capture and this will become the initiator. So if I ping 192.168, what is the IP? 2.2 and source is my loopback, I believe S1, and start ping. So let's see. Yes, one packet lost, but I already capture here. So here you will see if I type ISA KMP, this one, here is the 6 packet ISA KMP protocol, because I told you IKE will get help from the ISA KMP Internet Security Association Key Management Protocol for the first phase. So this is phase 1. There are 6 packets, 1, 2, 3, 4, 5, 6 packets. So because R1, which is 111, is an initiator and this one is responder, so R1 will send their detail. So if we check the first packet, so this is initiator because he starts, so it's become initiator number, and they exchange their detail, and we are using IKE version 1, which is mentioned here, and this is a main mode because I told you we are using 6 packet. So this is main mode, and there is a security association. So if I click on security association and if I go to payload proposal, so this is the proposal which they send. And this proposal, they say that where is, okay, let me open a proposal. Here is. So in the proposal they say that I am using 3DS for encryption. For hashing algorithm I am using SHA. For DP-Hellman I am using 2. DP-Hellman group 2. For authentication I am using pre-share key, and my lifetime duration is this one. So they send the packet, they tell me what about you? Do you accept all these things, and where we configure these? This is here which I show you. If I go to show crypto ISA KMP policy, so these are the things which mentioned here, and also show running section ISA KMP. So here we configure 3DS, pre-share key, group 2. So these things are mentioned here which sent by the R1 that somebody configure these. These are my proposal. So R2 will responder will also send the detail that yes, similar thing is configured by one person on this side as well. So we have same things. So these are the 6 packet which they exchange with each other if you are using main mode and phase 1. Keep in mind these 6 packet are phase 1. The other 3 packet quick mode, this is called phase 2, which we will discuss a bit later. So where I was, yeah. So the way responders send own proposal, because they send them the own proposal, the initiator will start DP-Hellman key. So in the next packet, then they send the proposal, responders send the proposal. Now in this one there is a key exchange. They will exchange the DP-Hellman keys, which we discuss in detail what is DP-Hellman and how it is work, and nonce value, and also there is a nonce random value as well. So there will be nonce, yeah, this one. So they will exchange in the next packet for DP-Hellman to decide a pre-share key. I told you how DP-Hellman work. They will exchange some information, the other side will exchange some information. Then there will be a mode, there will be another, there will be multiply and so many things. And finally they will decide a pre-share key, even though they will not share the pre-share key with each other, but they will decide to exchange these number with each other. And those number are the nonce value, and there is a DP-Hellman key which they exchange. So you need to go through that lecture how it is work. And the responder will do the same. So the 4th packet also they exchange the key and nonce value as well. So 4 packet are done, and the responder will start DP-Hellman, and last 2 messages are encrypted, used for identification and authentication of each other. So finally the last 2 messages will be encrypted. That's why these two messages are encrypted, we cannot see, and they are using this for identification each other and authentication to each peers. And then the first tunnel is done, which is a phase 1 tunnel, management tunnel, which is a management traffic, and these are the main modes, so they are using 6 packets. And this is the way. So this is the first packet initiator, and this is a responder. So security association, they exchange the proposal, and then their fifth packet announce and the value which I told you, and similar they will do, and finally they will authenticate each other. So 3 packet from this side and 3 packet from this side, and this is a main mode. This is initiator who start the communication, and this one is become the responder. So negotiation crypto setting, and this one is secret key exchange, which is a DP-Hellman, and finally prove identity. So these are the 3 different way for the main mode, and I show you here. These are the 6 packet and Wireshark which you can see. Now if you are using aggressive mode, so aggressive mode require only 3 packet to exchange. Similar thing which we are doing in phase 1 to exchange the information with each other using 6 packet, we're gonna achieve the same thing in 3 packet. So you can say aggressive mode is a T20 and main mode is a test match. So you will do all the thing in aggressive mode in 3 packets. So I believe if I configure aggressive mode, let me see if I configure aggressive mode. No, I thought maybe configure 1 2 3 I configure aggressive mode, but I don't think so. Let me see, because for aggressive mode I need to change some things so that I can show you. Anyway, in another video I show you aggressive mode 3 messages. So whatever I mention in 6 message, they will exchange them in 3 messages, whatever they do. So the main difference between aggressive mode, first message include DH key exchange as well. So it means in Ike phase 1 aggressive mode is quicker than the main mode, but exchange is in clear text. So it's dangerous to use the aggressive mode. So if you are playing T20 in aggressive style, so it's dangerous, you can be out anytime. So first message sent from the initiator includes security association, proposal, and transform payload. So they send each and everything in the first message. The main difference is in aggressive mode, first message include DP-Hellman key exchange as well. So it means aggressive mode exchange the nonce payload and the first message as well. An identification payload are added in the first message, which is in clear text, not encrypted. So this is the difference. The thing which they were sending in the third packet, they are sending them in the first packet. And also it is in clear text as well. So it's very dangerous to use aggressive mode, but it's faster than the main mode if you are using. So this is the way. So this is the initiator, they send security association, then the nonce value, then the DP-Hellman key, and then other information in the first place. So you see it is a difference between here, this thing, and they both combine them in one packet. Here is combined in one packet, and then the other side also responds with security association, nonce value, DP-Hellman, and all authentication, everything in the second packet, and finally they will prove their identity. So here is negotiation crypto settings, secret key exchange, which is DP-Hellman, and similarly they will do the same thing, the responder. So they combine all those things which was there in 4 packets, they done it in 2 packets, and the last 2 packet which was here, this one to authenticate and prove identity, so in 3 messages they done it in 1. So this is the main difference, and you wanna see here if you capture in Wireshark, so it will be aggressive 3 packet. So this was phase 1, 2 different mode, which mode you want to use. And definitely there is Ike phase 2, which is IPsec association information to exchange, which I show you above and also here. So this is the second tunnel where they will exchange IPsec policies such as encapsulation, if you are using authentication header or ESP. So I believe here we are using ESP. So if I say ESP, so this is ESP, I'm using ESP. And if you are using on this side, I believe I'm using AH. So if I ping this side, so you will see AH as well. So let me ping, if I can ping this time 3.3, the other router. So if I go to 3.3, okay, and if I go there and type AH, so there is, you see, it's visible each and everything, but in EH is not visible. There is a separate topic that if you are using AH or ESP. But in phase 2, there is only one mode, which is called quick mode. And there are 3 messages exchange. So if I type Isaac KMP again, so you're gonna see here quick mode. So here is quick mode, 3 packets are there only. And which is all of them are already encrypted, because these packet there is another tunnel already which cover this tunnel as well. So the 3 packets are already encrypted, okay, and this is phase 2, we call them phase 2. 3 messages are exchanged. Messages exchanged in phase 2 are protected by encryption and authentication, definitely, because IKE version 1 phase 2 quick mode using the key, because already another mode is running, so it's already secure by another tunnel, and also you make another tunnel, which is data tunnel, we call them a data tunnel as well. Now in IKE version 1 phase 2, negotiation about encryption algorithm, similarly hashing algorithm, because here they will also exchange the similar thing, that what will be the encapsulating and what will be the encryption, what will be the hashing, and tunnel mode. Also the tunnel mode, there are 2 mode, tunnel mode and transport mode as well, which I explain in next video. So they will exchange in phase 2 similar thing like a phase 1. They will also exchange many information, and there are only one mode which is called quick mode, and 3 messages will be exchanged, and these are the 3 messages, okay. And also, and finally, there is IKE version 2 as well. I told you there is IKE version 1 and IKE version 2. IKE version 1 has 2 phases, phase 1 and phase 2. Phase 1 has 2 mode, which is a quick mode, aggressive mode and man mode. While in phase 2 there are only one mode, which is quick mode. Now coming to IKE version 2. So IKE version 2 is quicker than IKE version 1. It's faster. It requires less packet to exchange. By the way, there is no concept of phases in IKE version 2. I'm talking about IKE version 2. The first phase, there is no phase, but you can say the first phase is no IKE security association in it, and second phase is called IKE authentication. And only 4 messages are required for the entire exchange. So it's required less messages, because and there was 6 messages and 3 messages, and then 3 messages for the second phase. Here entirely you require 4 messages. So it's more faster than IKE version 1. Also it's require less CPU and RAM. Also IKE version 2 is less resources required. Also less messages is required. And internet key exchange IKE version 2 use port number 545 if you are using a net traversal. Device configuration IKE version 2 accept packet from these 2. IKE version 2 IPsec pair can be validated using pre-share key certificate or EAP. Similar like the IKE version 1, you can use pre-share key or certificate. So this is the 4 messages which I told you. They can exchange the 4 messages with each other, and the after message 1 and 2, next message is protected to encrypt and authenticate. So definitely in the message 1 and message 2, they will exchange the details such as DH key, nonce, similar like the first one, and after that they will after message 1 and 2, the rest of the 2 messages will be encrypted, because there are only 4 messages. It's like this: 1 2 3 4. Initiator request, responder response, initiator request, responder response. So 4 messages are there, and the entire communication IKE phase. There is no mode, but you can say mode. It's not mode, but you can call them phases. IKE SA and IKE authentication. These 2 are the mode, you can say. Is basically it's not mode, but if you say so, it's a mode. So this is the first message from initiator to responder, where they contain security proposal, authentication, encryption, integrity, DP-Hellman key, and nonce value. This is the first message sent by the IPsec initiator. And then the second message, they will do the same thing. And third and fourth message are authentication, which will be encrypted. Similar concept like a IKE 1. So this is called IKE version 2, which I did not explain you in more detail, because our main focus is in IKE version 1, and there are 2 phases, and there are 2 mode in phase 1 and 1 mode in phase 2. So we explain this one. I hope so you understand why we are using internet key exchange and what is the purpose, okay, and how it is work.